sweetie boy. Okay, welcome to the next lesson. I think this is the fourth lesson for the GCSE Maths content. So last week we covered the kind of basics of trigonometry. So that's when you have a right-angled triangle and you want to work out an angle or a side, and you get given either two sides or maybe you get an angle on a side. Okay, now I was using SOHCAHTOA that we did a lot of. Now, sometimes, and this is actually most of the time, you get a triangle that isn't a right-angled triangle, okay? So not right angled triangles. Okay, and what we're going to be doing this week and next week is covering exactly how we can work with non-right angled triangles. Now, if they're isosceles, so you can split them down the middle and get two right angled triangles, but again, not all triangles are isosceles either. So we have to think of something that we need to use there. So today, what we'll cover is something called the sine rule. Okay, this is one of two rules that we're going to be using to work out sides and angles. And the sine rule is kinda fancy. What it states is that sine A over A is equal to sine B over B, which is equal to sine C over C. And the top three are all angles, okay? So if you want to work out an angle, this is the one to use. And you can rearrange this for sides too, but some people prefer to also remember the side version. So this is the angle version. Again, you don't need to remember both. But if you want to work out the sides instead, you just flip the whole thing on its head. So A over sine A equals B over sine B equals C over sine C. Okay? So again, you don't need to remember the two different versions, just remember one version, and it's literally sine of an angle over the side equals that. So you might be thinking, what on earth am I talking about? Well, let's draw a generic non-right angle triangle. Okay, so this is our triangle here. In fact, let me draw that a little bit better. Actually, let me make it a bit bigger. Okay. That's not a right angle triangle, it's just a generic triangle, okay? Now the question is, what are angles A, B, and C? It doesn't matter, okay? You can just label them whatever you want, okay? So I can label this one A, this one B, this one C. Doesn't make a difference, okay? So you might think, well, what's the point in labeling them? Well, I'm actually going to show you a bit later on. I would always recommend using the letters A and B and just write them as the sides or angles that you have, okay? Now, what does matter now is where you put the lowercase letters A, B, and C, okay? So, capital A is always opposite side A. Capital B is always opposite side B, and capital C is always opposite side C. That matters, everything else doesn't. So if you label this B, A, C instead, so rejig all the letters around, as long as the capital letter is opposite the lowercase letter, you're fine. Okay? So you can easily label it backwards if you want. Okay, so swap all of the B's and C's around and then all the A's and B's around, you still get something that works perfectly fine, okay? So you might think, well, how the hell do I use this in an actual calculation then? So let's start going through it, okay? So this might look complicated now, but watch. Okay? The important thing that the sine rule says is that the sine of an angle divided by the side that's opposite it equals the sine of another angle divided by the side that it's opposite. So all you really need is you need one angle side pair and then plus one angle or side, and you want to work out one. And you want to work what one of those out is. So if they give you the angle, you're trying to work out the side. If you're trying to work out the side, you'll get given the angle. Okay? But other than that, you need one pair. Okay? So an angle that is opposite a side, both of which you know. Then you either want an angle or a side, and you want to work out the opposite one. So let's go through an example. Okay, so I'm looking at this. Now, I do have a pair. I have 13 and 100. They're opposite each other, so I have a pair. So why don't I label this angle A and this side A? Yeah? I have another angle, so let's label that B. Again, it doesn't matter if it's B or C. You could label it C if you want to. And the side opposite is X. That's it. So now what we can do, and again, if you want, you can use the side version, or you can use the angle version. So if I do this, the angle version first, again, keep in mind, it doesn't matter which way you do it. We have sine of 100 divided by 13 equals sine of 38 over x, and they're asking me to work out what x is. That's it. Now, if you did this in terms of sides, then you flip the whole thing over. 13 over sine 100. Again, it's just the angle side pair. Equals x over sine 38. Okay? Now, I actually do have a calculator here, so I can do the calculation in front of you, okay? So I actually always use just the angle side, because rearranging is second nature to me, okay? So, for example, if I were to rearrange this, I would literally just get x equals 13 sine 38 over sine 100, okay? But I only know that because I've rearranged about 4 million times in my brain, okay? So that's my answer. But let's see how we get to that. So if we go down here, I want to times both sides by x to bring x to the top. And I get x sine 100 over 13 equals sine 38. Then I times by 13. I get x equals 13 sine 38. Sorry, x sine 100. In fact, let's start that bit again because that's a bit messy. So we have x sine 100 equals 13 sine 38. Divide by sine 100. And remember, sine 100 is just a number, so it doesn't actually matter. Okay, and we get x equals 13 sine 38 over sine 100. And I hope that you can see that if I rearranged this equation, I would get the exact same thing, because all I'd need to do is times both sides by sine 38. Okay? So the value of sine 100, will they ask it in the GCSE? So you won't ever have to kind of do it in your head or anything like that. So what you'll do is use a calculator. So the sine rule is going to be calculator only. Okay? So in terms of the ones that you have to know, sine 100 isn't one of them. You need to know 45 and 60 and 90, okay? But yeah, perfect. So either way you want to rearrange it is perfectly fine, okay? So you can either do it the side way or the angle way. It doesn't make a difference. But now if we go to the calculator, all we're going to do is enter that exactly as it looks, okay? Oh, and player, did you want me to repeat anything, or did you manage to catch everything? 13 sine. Sine. Okay, no worries. Cool. I've entered this exactly into my calculator. I press equals and I get 8.127 blah blah blah. Chances are you're going to get a long decimal. So, yeah, no worries. That's fine. Chances are you get a long decimal, so I would always round to 3 significant figures, which is 8.13. Thank you very much. I appreciate that. 8.13 centimeters. Okay, and again, this is the 3 significant figures. Okay, so we did get a much larger decimal, a longer decimal, not larger. But all I've done is kind of rounded it. Okay. So you might think this is quite a lot, but this is 3 marks. And keep in mind, I did manage to get to this step almost immediately. Again, I don't expect you to be able to do that just yet, but by the time of your exam, I guarantee you will be, because you would have done 100 of these questions. Okay, but this is a calculator-only topic. So I think we should just give it another go then. So if we look at the next question, again, this is a triangle. It's not a right angle triangle. Question, how do we know if it is a right angle triangle or not? Well, if they don't tell you, then you can't assume unless you can prove it. Okay, so for example, if I could take both of these away from 180 and it was 90, then I can, but it's not. So again, do we have a side and angle pair? Well, I have this 5 meters, which is opposite the 53 degrees. So let's label it A, opposite side A. So you might be thinking, well, what if we just use the letters they've given us? Doesn't matter. If you want to use the letters they give you, totally fine. So we can change this to a C, because the letters don't mean anything. The only thing that matters is you have an opposite side. Okay? And the other angle we have, again, I'm going to call it B, because it really doesn't matter. And the side opposite is lowercase b, which happens to be the thing that they want us to work out. So this is perfect. Okay? So all we need to do is, again, use our formula. We're working out a side, so if you want to rearrange the whole thing or just use the side version, it's up to you. So again, I'd write the side version over here. It is quicker to rearrange, but some people don't like memorizing multiple formulas. I don't blame them. So A over sine A equals B over sine B. But I'm going to rearrange it as well, just for those of you that might prefer just learning one formula. So we have sine A over A equals sine B over B. And again, we're looking for B. So for this side, all we do is times both sides by sine capital B. and we get b is equal to lowercase a sine big B over sine A. Also, if you prefer substituting in first as well, that's also perfectly fine. It doesn't really make a difference. For this one, again, we times both sides by b, and we get b sine capital A over lowercase a equals sine capital B. Then I'm going to times both sides by a to get rid of the fractions, because we all hate fractions. B sine capital A equals lowercase a sine capital B. Lastly, divide by sine A. And as you can see, if I draw this back up the top, we get the exact same formula as what we got with the other method. Okay, so you might have noticed that I don't really use C and sine C despite it being in the formula. All it really means is that all three pairs are equal. I've never seen a case where you need to use all three. So realistically, you just need to know A and B anyway. Now to do the substitution, A is 5 meters in this case. Sine B, again, make sure you don't get the angles confused, because it's very easy to do that. It's 42 degrees in this case. And A is 53. With your calculators as well, some students get the wrong answer and they're not sure why. So if I make this a bit bigger, in fact I want to make it a lot bigger. If you see this capital D that's highlighted, that means you are in degrees mode, which you should be, okay? If you don't see this capital D, you're going to get the wrong answer whenever you use trigonometry, okay? And if you want to kind of get back to normal, you need to just change the units. So you press Shift Menu, and if you see number 2 angle unit, make sure you press number 1 for degrees. The other two things, so radians are what you use in A level, so we don't need to worry about that yet. Gradians is something they only use in the military, so you probably won't ever use that. But yeah, just press number 1 and we're definitely in degrees mode, and that D should be highlighted. Okay. So now what I'm going to do is literally type in exactly what I've written out. And again, this is why I like having working out. 5. Actually, I'll make the calculator a bit bigger because it might be hard to see. Sine 42, close bracket, over sine 53. And again, I don't need to think about it. I'm just putting the numbers in. 4.1892, blah, blah, blah. So let's again do it to 3 significant figures. And again, we need to use units. It's meters in this case. So a question that you might have is, how do you know how many significant figures to do it to? Well, in this case, they give me the number of significant figures. They say 3. So do it to 3. Sometimes they ask you for 2 decimal places. So don't just always do 3 significant figures, because you'll drop a mark if you don't have the right number. Just double check the question. Because again, if they say 2 decimal places and you do 3 significant figures, you can drop a mark. If they don't say anything, 3 significant figures. That's it. Perfect. So far, I don't think this is particularly difficult. I think this is okay. But keep in mind, we're going on to the cosine rule next, and then doing the areas of triangles. You may have to use all of these together at once. So be really, really sure you're okay with this before we get onto the more complicated stuff. Okay. So again, sine rule is the easiest one. So if you're not sure, then please let me know, because cosine rule is a lot more difficult. Not to scare you. Thank you very much for joining in, player. I appreciate it. Okay. So, next we have, again, an angle side pair. So, what we need to do here is label it. Again, I'm going to label it A because it doesn't matter. So, A, and then the opposite side has to also be A, but in this case, lowercase. The angle is something, we don't know it, but it's what we need to work out. Okay, so I'm going to label that B. And the opposite side is 5.4 centimeters. Again, please make sure that you are looking at the units. You drop a mark for units as well. They're very, very picky. Okay? And guess what we do now? We do the same thing. We have sine A over A equals sine B. But you might be happy to know that you don't actually need to rearrange this much, because look at what we want to find out. We want to find out capital B, which is already on top. So it's a bit easier to rearrange. Times both sides by B and you're done. You have sine B equals lowercase b sine capital A over lowercase a. Good. Now here's the interesting bit. When you work out an angle, if I look at my left hand side, I don't just have an angle. Okay, what I have is sine B, which is not an angle. Okay? B is an angle. So I need to get rid of sine. And the way you do that is you do the sine inverse, okay? I'll explain what this is in just 2 seconds. But let me write this out. When I inverse sine something that has sine, it just becomes B. Then I do sine to the minus 1, big bracket, B sine A over A. So you may look at this and think, wow, this is a bit complicated. That's good, right? When you have these big math equations, you look smart and you sound smart. So if you show your parents an equation like this, people will go, oh my God, or your parents will. But it's not hard. Not hard at all. And I'll show you exactly how to do it. Okay? So we have B equals, now let's substitute those numbers in. Inverse sine, lowercase b is 5.4. Then sine of big A, which is 95 degrees. And again, I'm going to put those in brackets too. Over lowercase a, which is 6.7. And I shove that in my calculator. Exactly as it looks. So, fraction button. Actually, before that, so you press on, fresh calculator. We need to do this sine inverse because it's the thing, outermost thing. So if you look where it says sine, again, I'll make this calculator a wee bit bigger. Oh God. There we are. You have sine, cos, and tan. Sine should be a different colour, the sine to the minus 1 bit. The way you get that is you press the shift button and sine. So the reason why, so if you have a different calculator, you might be panicking. Don't worry. This sine to the minus 1 is yellow, so I pressed the yellow button. If it's red, then I press the red button. If it's some other colour, you press the button that corresponds to that colour. And it'll always be at the top. Okay? So in this case, it's in yellow, so I pressed shift. That's literally as difficult as it gets, okay? So then all we need to do is fill in the rest of this, okay? So fraction button, because that's the next bit. Then you put the 5.4, sine 95. So for those of you that have just joined, we're just doing the sine rule. If you want me to go over it, I'll go over this question one more time. But if you're okay, then just let me know. Go down, 6.7. And then close bracket, equals, done. 53.4. And again, 3 significant figures. So 53.4. The units are degrees. Okay. And I hope that that was not too shabby. It's not too bad once you get the hang of it, I promise. And again, I'm going to write 3 significant figures. Just to make it seem okay. So guess what we're doing now? We're doing the exact same thing again. Okay, so again, I know it might be a bit tedious now, but practice is key. If you understand it now, that's brilliant. But keep in mind, if you then came across a question in a month, would you remember it? What about 2 months? So everyone that's watching this now probably has at least 8 months until their exam. So just be conscious of what you're going to actually remember in at least 8 months. So make sure you're practicing this regularly, okay? Or, again, just do 1,000 questions now and you never have to do it again. Except in your exam, of course. Cool. So once again, label up the side. So this is the one we have, so I'm going to call it A. This is the side we have, so I'm going to call it lowercase a. The angle we want, let's call capital B. So we want, let's call lowercase b. Nice and easy, right? Work out the size of the angle. Okay. So again, let's do sine A over A equals sine B over B. Multiply both sides by B, and we get that sine B equals lowercase b sine big A all over lowercase a. Once again, we're looking for an angle, so let us inverse sine both sides to get -1 b lowercase b sine capital A over lowercase a, and we're done. Now we just need to sub in the numbers, okay? B is 10, not too bad. Sine of 60. Lowercase a is 15. So then b is just equal to, well, let's work out what b is equal to by doing it on our calculator. So I could cheat and just edit what's in here, but given that it's unlikely you'll get 2 sine rules in a row, I'm going to reset it. So again, shift, sine, inverse sine. Again, I'm working outwards in, okay? Fraction button, because that's the next bit. 10 sine 60, ooh, almost for 61. Over 15, bracket. 35.3, because it's rounding to 3 significant figures. So 35.3. Okay. So even though this rule looked really complicated at the beginning, I hope you realise, or you're starting to realise, that it's actually not as bad as it might seem. And this is true for a lot of maths, okay? Maths can seem very intimidating at first and scary, but it's designed to be at least shortcuts to working stuff out, okay? And it may not seem that way, and I get that. But once you do a bit of practice, everything does become easier, including maths, okay? And working out a length again, AC. Here we go, right? Ah. Yes. I've already seen something very interesting in this question. Very interesting indeed. So we're looking for the length AC, which is this one here. I'm going to label it X for now. Okay. Now you might notice we don't have the angle opposite. Right, we don't have this one. But can we work it out? I think we can. So let's label this angle A and this side A. I'm going to label this angle B, which is the same as what the question says, and this side B. Angle B I can work out. Okay? Because so the angles in a triangle. Again, I'm writing like a caveman. Add to 180 degrees. We have 2 of the angles already. So angle B should be 180 minus 20 minus 55. So 180 minus 75, which is 105 degrees. If you want, you can add it to your diagram if it helps you visualize. But now we're just looking for the opposite side. We've done this 1,000 times already today. Well, about 5, but you know. So that should be A-OK. Cool. So now, whoops, I'm going to do sine A over A again. And once again, you can use the method for working out sides. Okay, that's completely fine. I won't judge you. Okay. And then we can rearrange it for B. So if I rearrange this for B, I times both sides by B. And again, to do that on this side, I just times both sides by sine B. times both sides by A. Divide both sides by sine A. B equals A sine B. Whoops, that was a dreadful mistake. Over sine A. So again, you might wonder, why would you not just use just use the method for remembering two equations? But some people don't like doing it, and that's totally fine. It's up to you. I don't think rearranging is that difficult, because I can go straight from here to here. Because if you notice, and go back through the video if you don't notice this yet, but it actually has the same pattern every time. Okay? So it's A, so it's the side, the other side, times the same angle over the other angle. If that makes sense. Okay, so now what does B equal? So B equals, side A was 12 centimeters. Angle B, if I remember rightly, was 105 degrees. And angle A was 55 degrees. So now we just shove this all into our calculators. 12 sine 105, close bracket, sine 55. 14, does it say one decimal place? See, they changed it. Although in this case, 3 significant figures in one decimal place would give you the same answer. You get 14.2 centimeters. Remember the units. They're very, very intense. We don't like it. Not bad so far. We're making extremely good time for the questions that I have for us. But again, I encourage you to go and do some questions yourself. If you're not sure where to get questions from, you have places like Math Genie, Pixie Maths as well, Corbett Maths. All of these places are very good. Or you can just start looking through past papers, getting yourself familiar with those. Okay. So if you could bear with me 1 second, I need some water. Okay. Fun times. We want to work out the size of angle BAC. So I want to label that first. If you remember, the angle is always at the middle letter. So it's this angle here. Always. The reason why there's a B and C there is, if you look, this angle's made from side BA and AC. So that's why it has BA, AC in there. Okay? And we need to work out the size of the angle. Perfect. So again, we can call this angle A, this side A, this angle B, side B. If you want to call it C, you can. Really doesn't make a difference. And we're working at an angle, which is quite nice. So sine A over A, sine B for B. And we want angle A, so just times both sides by little a. We have sine of angle A, so big A, equals A sine capital B over lowercase b. And again, since we're working out an angle, what we want to do is inverse sine it. So we have A equals inverse sine A sine B. Oh God, don't know why I'm struggling to write. Now let's sub in the numbers. A is 20, and it's in meters this time. Sine of angle B, which is 43, over 14. And it says to 3 sig fig, so let's do this. Inverse sine is shift sine, inverse cos is shift cos, and inverse tan is shift tan, shockingly. 20 sine 3 over 14. 76.97. Okay. So this would be 77.0. Okay. So the reason why that's important is because we need to show we actually did it 3SF. So we put the 0.0 in there because we actually rounded up to the next unit. Fair enough. And that is everything I have for today. So again, it might seem like a shorter lesson. Technically, we were supposed to do it last week, but it took a lot longer to do the SOHCAHTOA stuff. But I'll give you a few moments to ask any questions you may have. Those of you that are left in here. And in the meantime, I just want to say that, again, these lessons are live, okay? And a few of you are making use of the chat function, so to actually ask me questions. Don't underestimate how important that is. Okay, so some of you, when you're in maths class, you might realise that you don't always get the chance to speak to your teacher. With this, you basically have unlimited access to me. I can see the question, I can answer it immediately. You don't have to wait in line, so to speak. But again, these are taking place every Tuesday from 6 p.m. to 7 p.m. between those hours. So it should be up to an hour long, but this one's only been 30 minutes. Okay, but if there are no other questions, then I'm happy to end it here. Okay, seems good. Well then, I will see you guys in the next one. I hope you have a truly wonderful evening and rest of the week.